All right, hello everyone, and welcome back to another video on logic. I hope you enjoyed the first one. I know it's a lot to take in. Today we're going to be doing the conditional. We're going to look at equivalents and variations of the conditional. And so let's talk about what this is. Alternative phrasings of conditionals. So we looked at if P, then Q, but let's look at some ordinary language where you would see a statement and it actually is a conditional. It's just not said as if then. So in ordinary language, conditional statements don't always appear in the standard form of if P then Q. For example, the statement, I'm not coming back if I leave, is the same as if I leave, then I'm not coming back. So that's just one of the things I wanted to put on here, that when you see phrasing, especially when you're working on the homework, if it's a conditional, right, I'm not coming back if I leave, it's just written differently than your typical if then. So look out for those phrasings. Here's some, and I have a chart, this is in your notes. Here are some common alternative ways of stating if P then Q. P is sufficient for, or you might see Q is necessary for P. P will lead to Q. Q if P. P implies Q, or Q whenever P. These are different keywords that you might see in a sentence, and it still means an if then. And let's do some examples. What we're going to do is we're going to recast each of the following statements in the form if P, then Q. This says, a rise in sea level will devastate Florida. Okay, this is actually a conditional because what are we saying? We're saying if the sea levels rise, right? Because it's saying a rise in sea levels will what? Devastate Florida. Then if sea levels rise, then Florida will be devastated. Okay, that's how we would write this back as your if P, then Q. What you're going to need to do is look for key words. Let's look at number 2. A red tag on an item is sufficient to indicate it's on sale. All right, is sufficient to, that we kind of looked at that in the chart. In other words, if let me just put if an item has a red tag on it, then it is on sale. There's your condition, right? If it has a red item, then it is on sale. One more. Eating vegetables is necessary for good health. Go back up to this table. Notice what it looks like. Q is the first one. So when we say is necessary for, the Q statement was first. But use this table to kind of help you with this. But what we're saying then, if a person is in good health, so what I meant by when we went back up to that chart, this is your Q and this is your P, because it said the Q would be first. If a person is in good health, then the person eats vegetables. Now, we're not talking about true and false on any of this, so don't sit there if you're saying, but that doesn't always mean something. No, we're not looking at that right now. We're just putting sentences together. Later on, we can look at true and false, but right now we're just rearranging our sentences. Now let's go down here. Here are variations of the conditional. This is what we call them. All 4 of these right here are what we call variations of the conditional because they are different ways that we can write. There are different variations, sorry. So let's talk about the conditional. That's your usual, right? Your if P then Q. There's your conditional. What we call the converse is when we reversed it, flipped it. If Q, then P. So if we flip it, it's the converse. If we negate the conditional, right, that means we're just saying if not P, then not Q. That would be the inverse. If we negate the converse, notice over here, if not Q, then not P, that would be called the contrapositive. So in other words, the inverse is literally the inverse of the conditional, and the contrapositive is the inverse of the converse. Anyway, these are your variations of the conditional and what they are called. And you can use your notes when you're looking at these. Let's just try something. Here's our discussion. P is going to represent you live in Orlando. Q is going to represent you live in Florida. We want to find the converse, the inverse, and the contrapositive. So we know that the conditional is if P, then Q. That would be if you live in Florida, or sorry, if you live in Orlando, then you live in Florida. But now let's find the converse. So the converse, remember, I'll put this in like parentheses. So the converse is if Q, then P. So just a reminder from your notes. Then that means I would say if you live in Florida, then you live in Orlando. That would be the converse. All right, now let's do the inverse. Well, remember the inverse is basically you're inversing the inverse of the conditional. So that would mean I would say if you do not live in Orlando, then you do not live in Florida. That would be the inverse. Now let's do the contrapositive. Remember, that's if not Q, then not P. Well, now I reverse everything. So if you do not live in, oops, I just lost my place, Florida, then you do not live in Orlando. That is how you would write each of those out when you are looking at the converse, inverse, and the contrapositive. Now let's go down to the truth table for these. Yes, fun times, right? We love truth tables. Okay, reviewing from last video. Remember with the P's, we've already talked about the pattern and how we get the pattern. So if you missed that, watch my video on logic, which is on the basic concepts video. That will give you into how we set up these truth tables. Not P. Remember, that just means we make everything the opposite of what we just put in the P column. And not Q is the opposite of what we put in the, I'm not sure why it keeps doing this today, what we put into the Q column. So we're going to do the opposite. All right. Now I go back up here. If P, then Q. Now this part was covered in the first video, the recent video on the logic basic concepts. We had said that in order for a conditional to be true, oh, well, actually, let's go the opposite way. In order for a conditional to be false, the condition had to have been met, but you didn't get what you were supposed to get. In other words, the only time this is false is when P is true and Q is false. Let me find that. Not here, right here. P is true, Q is false. That is the only time it is false. Otherwise, it's true because everything was met. But now we got to go the other way. That means we're kind of looking at it reverse. If Q, so we're going to do the same thing. The only time this right here is going to be false is if Q is true and P is false. Remember, the only time it's false, let me just write that up here. That's it, is when the first is true and the second is false. So, but I have to go this way, okay, from right to left because we're doing P is considered the first one, or Q is considered the first one. Right here we're fine. P is false, or Q is false too. Nope, that's good. Here, third row, Q is true, P is false. That makes this false. Everything else is true. Over here, let's look over here at the inverse. Now we're going to do the same thing, but we're looking at the not P and the not Q columns. Again, the only time this is going to be false is when the first is true and the second is false. So let's go down here. I don't have the first true, so we're good here. And it's in the third row. First is true, second is false. That's the only time it's false. So that means every other one will be true. And now we do this one, but we're going the opposite way. I find that this way is usually harder because you got to remember which one is true first and which one is second. So now we're looking, again, first true, second false equals a false. So we're looking at this way. First true, that happens right here in the second row. The first is true, the second is false, that's false. Everything else is fine. Okay, now I want you to look at something here. Notice last week we talked about conditional statements. So when we were looking at conditional statements, then we talked about equivalencies, right? Equivalent statements. Those were the statements when at the end, they shared the exact final column, the final one. Notice with this one, I have true, false, true, true. Okay, that's my final results of everything. Do I have that anywhere else? Yeah, right here. True, false, true, true. So if you notice, the conditional and the contrapositive are equivalent statements, meaning, oh, let me change a different color. Whether I have a conditional or I have the contrapositive, my result is going to be the same. But look here. Notice my converse. True, true, false, true. And my inverse, true, true, false, true. That means these two are equivalent. In other words, if you have the converse final column, the results, you automatically know what the inverse is because it will always be the same. So the conditional gives us the same results as the contrapositive, and the converse gives us the same result as the inverse. Hence, they are equivalent statements. All right, one more topic. De Morgan's Law. De Morgan's Law is looking at negations of a statement. And here is how it works. When you put a negation in front of the parentheses, what happens is you're going to make everything the opposite inside the parentheses. Your P will become negated. Your Q will become negated. And your sign flips. So the and becomes an or. This is what De Morgan's Law is. You're basically carrying through, distributing the negative, we call that, right? The negation through the parentheses, which makes everything the opposite, but it also changes. Instead of an and, it becomes an or. Look over here, same thing. Your P's and your Q's change, but your or now becomes an and. This is De Morgan's Law. This is what is called negating the entire parentheses. In other words, these are going to be the same. These are equivalent. So if you were to do a truth table, what you get for this result is going to be the same as the not P and not Q. What is the negation of if P then Q? Okay, here is the negation of if P then Q. It's P and not Q. Now, We could take time and do a truth table, but I don't want to use up too much of your time because I know that first video was a lot. But if you were if you were to do a truth table, you would find that the end result, your end column for this, would be the exact same as this. So just like up here, when we were saying that the converse gives you the same results as the inverse. Okay, well, that's the same here with our conditional. What you would get here for your end result would match this. This is why we can say that the opposite, the negation of if P then Q is actually P and not Q. All right, let's just try a quick example. P is the statement, I got a C. Q is the statement, I passed the course. What is the negation of? It is not the case that I got a C or I passed the course. Okay, it is not the case. That means I'm going to do the negation in front of the parenthesis. I got a C, that would be P, or I passed the course. That would be Q. Now, the reason why I'm starting this symbolically is for me, I just find it easier, and then I turn it into words after. You're welcome to do it how it's easier for you, but I prefer to do symbols first. Using De Morgan's law, this means that I negate the P and I negate the Q, and then I flip that so it becomes an and. Meaning, how would I say this out loud? I did not get a C, and I did not pass the course. So the opposite of it is not the case that I got a C or I passed the course would be I did not get a C and I did not pass the course. Now, before we end, I just want to show you something real quick because these were all simple negations. On the side here, if I had, let's say I had this, because I didn't give an example up there. I want to make sure I had that. De Morgan's law says that I make everything the opposite of what's inside. That means if I have a not P already, the opposite of that would be P. That would change to your and then I negate the Q because that was not negated before. So I just wanted to give you an example with that. If there's a negation inside the parentheses, it's almost like when you think of two negatives make a positive. I always kind of remember it that way, but this would become P and not Q. And that ends for this video. Thank you very much.